everybody, and welcome back. This is part 2 of the brake system that's on my 188-inch wingspan Emmaselle II. And there's going to be some video in this, basically me making the cam part for the brake, and I'll describe what that is in a minute. At the end of this, I talk a little bit about the next video. So let's get this rocket off the pad. So this is the Emmaselle II, and as you know, I designed brakes on it that are differential, and they are linear. They're not exponential in the way I've got them set up on my sticks. So on my radio, I have a finger dial that I can put the brakes on together. So as I land and I want to roll to a stop, I just basically push that up forward. Now, the reason I don't have them on my elevator like some people do is because on a tail dragger, I like to lock up my brakes and bring the throttle up and kind of fly the tail off the ground, or I like to lock up just one brake and spin on that landing gear. And that's on my rudder differentially, okay? So, what we're going to talk about and look at is on the left, the little black thing was a 3D printed cam, and I'll talk about the cam. If you haven't seen the first video, I'm going to try to explain some of this because some of you haven't seen the first video. If you've seen the first video, you understand what I'm doing. But basically, that little 3D printed thing is connected to a servo and it has a cam on it, and when it twists, it basically opens and closes brake shoes like on an old Volkswagen Bug from the 60s and 70s. But the white stuff here is called nylon 6. And I love this stuff because it's, if you type in nylon 6 at McMaster Car, it will lead you to the nylon. I call it nylon 6 because there is a material called nylon 6. But I'm not sure that McMaster Car calls it nylon 6. But essentially, it's incredibly strong. It's not quite as strong as aluminum, but when you're machining it and milling it, and put on a lathe, it cuts like butter. And I love this stuff for a lot of parts. If I've got to machine something, I hate to do it in steel. I'll reluctantly do it in aluminum if I need the strength, but most of the time nylon 6 will be strong enough for radio control aircraft. So when it was done, it looks like this. Once I machined and milled it. And now we're going to talk about what it is. So this is my landing gear brake. And this is it exploded. This is it explaining the part. If you look at the green thing, it says brake cam. That's what I was 3D printing, but it just wasn't strong enough. So if you look at the materials I use, I have 6061 T6 for the brake lining and 3D printed all of these parts. And then we're going to talk about that cam right there. So if you look at this picture right here, this is the top left-hand corner is the brake shoes touching the cam. Top right-hand is the servo that's on the inside of the brake that actuates the cam. Bottom left-hand is showing the brake lining, which is aluminum, and the bottom left and the bottom right is showing the brake shoes just laying inside there, okay? Before I get too far into this, I want to talk about my sponsor, RTL Fasteners. Incredibly cool company. If you need the anything that's 440, metric, blind nuts, nylocks, wood screws, anything you need for the hobby, they've got it. If you go to the website, spend more than $50 and use code DA30, you'll get 30% off any orders over $50. So I want to say that again. Buy $50 of product, use code DA30, and you'll get 30% off, which is awesome. So now we're going to talk about this cam. So if you look at the bottom left-hand corner, you can see this 3D printed. And I ran a 256 through the middle of it and put a nut on the end and grinded it off thinking that would reinforce it because I keep having this fail. Okay, the last time that I thought it failed was really just the brakes had worn a little bit and I hadn't readjusted the servo. But since I had the brakes all apart, I decided, what the heck, I'm just going to go ahead. I know these are going to break one day. So if you look right here, you can see the brake is actually actuated right now. You can see the cam is turned. And I'm going to take this little illustration and I'm going to show it to you a little bit better. And then we are going to look at that. And that's what it looks like when it is engaged. You can see the servo turn that little cam. when I went to machine it, I realized I didn't need to have that square. So I just left that circular like you saw in the early picture. Same thing with the camshaft. You know, the actual shaft, the round part, needed to be almost 9 millimeters. And instead of doing a true cam that engages slowly, I decided to make it more square so it just really instantly engaged. And I think I'll have a little bit more ability to adjust it if the brakes are wearing quicker than I think they should. And I always carry extra brake shoes with me. But I went all last summer with one pair of brake shoes on the entire airplane, and they had worn at the end of the year that they weren't quite engaging. But if I would have just went in and tweaked my servo, you know, go into my servo trim, I could have trimmed them up tighter. So basically, I have a Grizzly combination lathe and mill, and that's what I use to do this with. And you know, basically it is here, let's watch the video. So basically here in this video, I've sped this all up extremely fast because I don't want to sit here for 8 or 10 minutes. It actually took me about 15 minutes to make this part. And with nylon 6, my little bitty mill, you know, heads, bits don't wear and they don't break. With aluminum, if you're not careful, you can bend them. And it just cuts like butter. You got to do a lot of passes and take your time. And look, when you're doing it manually, all you got to do is go the wrong direction once and you've ruined your part and you got to start all over. So when I always cut my parts, I cut, if I'm going to do 2, I cut 4 parts. If I'm going to do like 6, I'll cut maybe 8 parts or 9 parts. I always cut a couple of extra ones just in case, you know, I screwed up. And believe me, you will if you're doing it manually. As many times as I've done it manually, you'll accidentally turn the wheel the wrong direction and you've screwed up your part. So when I was all done, you know, we basically had this part here, and it looked really, really, really cool. And I don't know, I love the nylon 6. It just worked out perfect. This is what it looks like that earlier picture when it was done. And it works perfect, everybody. You just got to take your time with this stuff. So here is a picture of the new cam in there, the nylon 6. And now what we're going to do is watch some video of it activating. And it's just slicker than snot, everybody. I mean, it works absolutely perfect. And I guess the thing that's most important is just take your time and fiddle with things. You're going to get it to work. It's all about just having patience. Everybody's so hyperactive nowadays. They want instant gratification on everything. You just got to take your time. And I mean, that's pretty much it. So when I'm done with it, basically I've got to make sure that the servos are adjusted so that the moment, it's hard to explain, but on my radio, if I pull this like wheel all the way back, and it's the one on the front of my transmitter that I use my fingers, if I pull that all the way to 0, I really don't have any brakes differentially at all with my rudder. There's nothing there at all. If I put it in the middle, now my brakes are engaging differentially with the rudder, but I don't have any braking together unless I push this forward. So if I'm going to take off, I'll put it in the middle, because a lot of times I want that differential braking as I'm taking off, especially when I'm first get rolling. Even though I have a tail wheel, I love to have that differential braking just to help control me going exactly down the runway. Especially if there's a crosswind, it's really cool how much differential braking helps. You know, I always turn the ailerons into the wind, and as I start to roll, you know, normally I'm going to hold a little bit of rudder, opposite rudder, to try to keep the tail from weather vaning. Well, that brake being engaged a little bit is really helping keep that plane straight, especially if I don't have any air over the rudder yet because I'm going so slow. So now I'm going to talk about this is not going to be the next video, but a video that's coming. As you all know, I 3D printed a dual twin-row radial engine on this airplane, which is a dummy. The electric motor's in the middle. I created an exhaust system on it where the red LEDs would flash inside the exhaust, making it look like flames. They weren't bright enough. I didn't like it, so I pulled the motor off, the engine off, and I am going through and redoing how I did the lights. So this is the controller that has 8 MOSFETs in it. It's got 2 little control boards there. A friend of mine, Berger, helped design the control boards for me and told me what MOSFETs to use. And then I 3D printed and made the harness for all the wiring in it. So this is the brains that makes the lights blink. So there's a servo wire that goes into it. Depending on where my throttle is, it changes how fast the firing order is. The old way was I had LEDs like this in the exhaust pipe, and they just weren't bright enough. They didn't work. In the evening or as the sun was setting, you could definitely see it. In the daytime, you couldn't see anything. So I bought some like really cool LEDs that are super bright. I'm going to get those done, but I'm going to do a video on that coming soon. So look, thanks a lot everybody for watching my videos. Please like, subscribe, and share my videos. There's so many people that says, I had no idea you did these videos, and I've been doing them for 10 years or so. So try to share the happiness, I guess. So rock on, everybody. Have an awesome day, and I'll see you next time. Be safe.